Welcome to solverfy.
This is the answer to Chapter 16, problem number 45 from the Smith Organic Chemistry textbook. And we're asked to draw a stepwise mechanism for this reaction. And so it is a hydrobromination of one of these two alkenes, and it's taking place under radical conditions. And so we learned this reaction in the previous chapter, chapter 15. And so hopefully you remember that when an alkene is treated with HBr under radical conditions, the bromine is going to end up on the carbon with more hydrogens. So this is going to be an anti-Markovnikov type reaction. And so the mechanism is going to look like this. So first, we're going to have our radical initiator species, so our peroxide species. And to begin with, the oxygen-oxygen bond is going to cleave homolytically. So that's where our radical comes from. Okay, so we now have this OR oxygen radical species, and that is going to be what interacts with our first equivalent of HBr. And so we end up having this happen. So we have the alcohol here now, and we also have a bromine radical. And so it's going to be this bromine radical that now actually adds to our starting material. So I'll draw the starting material just right here. Oops. Oh, wait, no, that's right. 1, 2, 3, 4. 2, 3, 4. Yeah, okay. So it's going to be this bromine radical that actually adds to our starting material. And so that's going to look like this. So it's going to be another radical process. And it's going to give us, well, not two products. It's going to give us a single product that is going to be an allylic radical. And so it's going to be able to rearrange. So this, with the radical here, is going to be the direct result of this radical bromination. But this can rearrange since it's allylic. And so when it rearranges, our double bond ends up here, and our radical ends up there. And so we have these two species, and this is what gives rise to our two possible products, because when we add another molecule of HBr here, so another HBr here, or another HBr here. So wherever the radical is situated, it's going to react. And so that's what accounts for our two possible products. Okay. And so that's the stepwise mechanism here. It is a radical process. Um, However, since this chapter, since we're really focusing in this problem on the fact that this is an allylic system, I didn't draw this as an initiation step, propagation steps, and then a termination step. We could draw it that way, but really we were just asked to account for the formation of these two products. And again, they form via the mechanism that I've drawn here. And we do get these two products because this is an allylic radical system, and so it can rearrange. And that's the answer to chapter 16, problem number 45.